Should be live. Hello, everyone. Give a minute or two for people to roll in. And as you join, say hello in the chat. It's always way more fun for me up here talking, but also hopefully more fun for you in the audience too. And put where you're watching from. Maybe also if you've used Flyte before. So today or this month's kind of office hours is about the Flyte 2 Devbox, which just launched this week, and I'll be showing that off. Me and Niels. Niels should be joining here shortly. We'll be talking about that. So we'll show a couple examples of what it is, but at a high level, so that if you're familiar with Flyte or Flyte 2, so Flyte's a orchestration platform that has a lot of really great reliability, durability features built in for workflow orchestration and model and app serving. And so the Devbox is the V2 version where you can run this locally on a single machine, and you get all the features of Flyte, but on your own machine. So we'll go walk through that. Welcome, Niels.
Hey, Sage, how's it going?
Good. And then I'll link to the blog post if people want to dive in to the blog post. Is kind of what I'm showing here. We're mostly just going to be sharing our screens and the actual platform and code. I don't think a lot of slides today. But there is kind of a breakdown of the blog. You can see if you want to use this today, it's out. It's open source. It's free. It's a UV pip install Flyte, which is the SDK, and then you can do a Flyte start Devbox if you have Docker already running, and then you'll get the platform that we're going to show you today. So, I'm not sure if Niels, did you want to show a workflow first?
Yeah. Let me share my screen.
And I see Virgil in the chat and John. And I know John's been using the Flyte 2 a lot, which has been awesome to see, which is also just built into the SDK. And then also the Union, which is like Union's hosted version of Flyte 2. So really cool to see that in the community Slack right now, the stuff that he's been working on.
All right, awesome. Cool, everyone. So yeah, Niels here, super excited to show off the Devbox a little bit. We just launched it this week, and I think Sage and I are both DGX Spark owners, proud DGX Spark owners. So we've been using it a lot. You can actually set this up on your own laptop, be it a Mac or whatever system you have. So what I'm showing you here is my cursor that's being hosted on my DGX box that I've called Flint, just personally. So yeah, what is Flyte Devbox? So I guess Sage already talked about this a little bit. Under the hood, you can think of this as a Docker container that is hosting a bunch of other Docker services under the hood. Some of those include the Flyte backend, the Flyte new Flyte UI, a Postgres database, and an object store, kind of like MinIO. I think we're using a different object store these days. I think like a Rust-based one. So let's take that down. So as you can see, I've already started a Devbox here on my terminal. The command to run is Flyte start Devbox. If you're just using a CPU. If you do happen to have a GPU and your host machine that you're running the Devbox on has CUDA enabled GPUs, so that is the limitation, it only supports CUDA, then you can say start Devbox -- GPU. I'm going to keep my cluster around, so I'm going to cancel this command. But yeah, I guess to take a step back, the first step would be to actually install Flyte. So, pip install Flyte. I use UV, so that would be UV pip install Flyte. Yeah, so when you run this, you should get that nice green box. And let me go to my browser. So this is the new Flyte UI. This is a source available UI that we've exposed. So this is basically we've taken a lot of our learnings from the Union Flyte v2 UI. We've made it available for everyone to use under the Union community license. So that's just one call out here. Everything is open source under Apache 2 license. The Flyte UI has a different license behind it. As you can see here, you see the projects. We only have one, Flyte Snacks. So Flyte Snacks, for all of you who don't know, is just kind of like our pet name for the default project that ships with the Flyte cluster. As you can see here, I've already run a bunch of stuff here. On the runs, there are some other entities here that we'll break down in a little bit. So runs are basically executions of tasks. I'll show you in a bit. Sage will also show off this new open source apps entity. So Flyte 2 ships with both, let's call it like batch workload functions. And so those are tasks. Triggers are how you would run those tasks, like on a schedule. Eventually, we will be supporting things like webhooks and stuff. So this is how you run the tasks in an automated machine triggered manner. And then apps are long-running services. So these are like things like fast API apps or Streamlit apps and VLLM apps if you're hosting LLMs or VLMs. So this is a new entity that we've open sourced in Flyte v2 that as I mentioned, Sage will show off in a little bit.
I just want to mention it's not just like it has the word apps, but it's models too, like you had mentioned VLMs, but you can have a long-running API that has a hosted model there. Yeah,
exactly. And so, I mean, the main conceptual difference between tasks and apps are that tasks are durable and inputs and outputs are tracked and have data lineage around them. So Flyte does a lot of hard work to make sure that if your mission critical tasks fail, they will be retried if properly configured. You don't have to run your entire 100-step pipeline from the beginning. It just picks up from where it left off. So those are tasks. Apps are not durable, right? So they're long-running services, but they are literally kind of like endpoints or web services that you can hit. You call an API endpoint on them, they'll return some response, and Flyte will not like track them in any way except for some logging. So let's go ahead and run a couple of simple workflows here. So, you know, we're going to do the good old classic, like basically regression here. I have like a function that has a hard-coded slope and intercept. I give it a list of numbers to basically predict on based on those numbers. And so the first thing you do with Flyte, the Flyte Devbox and Flyte in general, is you need to like connect it to some kind of cluster, right? So I can actually run this locally. So if I change this to with, and maybe this is just like a refresher for folks who haven't played around with Flyte before. For some reason, I don't have code completion here on my like SSH. So I'm just going to go off of memory here. Let's see if this works. Hello. Cool. So that ran locally. You didn't see it, but actually, let me print out the outputs here. I think this is a cool. All right. So we're calling the function on this list. We're taking the average prediction, and then 14 would be the value you get there. So if I change this to remote, what this will do is it's going to use, it'll look at various default places where to look for configs. But right now, I have my Flyte config file pointing to my local Devbox, some other configurations here that you don't really need to worry about too much. But if I now run this, actually it's using a local Docker builder and pushing to a local Docker registry that ships with the Devbox. So it's going to ship to that local registry, and now it is running the workflow. All right, cool. So as you can see here, we parallelized the function calls, and then up on the main, we see that the inputs are what we passed in the code, and then we got 14 as the output as well. So that's your sort of hello world where you parallelize things super easily with Flyte. As you can see, we're just using Flyte map. You could also use for loop here. I'm using sync Python here. Also supports async Python if you want to more easily parallelize things. The next two examples I show is just like a sanity check to make sure that the GPU actually is being used. And actually, this may take a few minutes because I'm not sure if I think it's going to rebuild stuff on Torch. So maybe while this is happening, I don't know if Sage, you have something ready to go, but let me just kick this off. I'm actually going to run a very simple grid search task that does a grid search over using PyTorch Lightning, which this is kind of the curse of the demo here. I believe Lightning as a package has been quarantined. Let me see if that's still the case. 1 second. Oh, and we're back. Okay. I think they resolved that quickly. All right. So let me just run this, and it may take a minute or so to build the image, because actually we're using, maybe I'll show off another little piece of cool thing that Flyte 2 has is it actually works really well with UV. So if you haven't used UV yet, I highly recommend it. And UV has a really nice thing where if you have a self-contained script, you can define all the dependencies up top here. So we were using Flyte, Torch, Lightning, etc. And what this is going to do is Flyte.image from UV script will actually pick up those dependencies and build the image without actually like you having to install a virtual environment yourself. So as you can see there, that's what it did. It built a virtual environment. Actually, okay, cool. So in my local registry, I do have the image already built. So it's going to kick off this grid search job. Again, we're only running, we're tuning over batch sizes, which is, I mean, people do that, but usually you would tune learning rate and other such hyperparameters. And as you can see, we requested 1 GPU here, 4 CPUs, memory, and actually I think I have HTOP installed here. Yeah, so you can see actually a lot of this memory is being used for a local LLM that I'm hosting on my DGX that I use for like various coding tasks. And yeah, we're using some of this compute power on here. And yeah, so grid search actually uses CPUs, while these train model subtasks that we call actions in Flyte 2 are being kicked off. There's only 1 GPU on this box, unless I cough up the cash for buying 2 or 3 more DGX Sparks. We'll only do this sequentially. So yeah, this is using the GPUs currently on my DGX Spark. And these results will be saved over time. I can do this, which is Flyte delete Devbox, and that'll delete the cluster. As far as I understand and as far as I've tested, this will actually persist the data that I have. So even if you delete the Devbox, the UI will go away and the services go away, but I think the actual data is persisted. So my job's done. It's actually saved to S3. So this S3 is being hosted again by the Devbox container. And so these will be available to me locally for me to poke around at. And I think, yeah, that's the demo. We've shown you basically that you can create a Devbox. If you're using your Mac, unfortunately, there is no container technology yet that allows Docker container to access Apple Silicon, like the M3, M4, whatever chips. Hopefully that'll happen eventually, and then we'll be able to do that. And for now, if you have a NVIDIA CUDA enabled GPU, you'll be able to run stuff on your GPU with the Devbox. And in every other case, you can just run Flyte start Devbox, and it will run on your CPU. Cool. And I'll pass it over to Sage for kind of a show and tell on apps.
Yeah, and before that too, I know John had a question about is the UI running on the Flyte Devbox container? They're assuming yes in this case.
Correct. Yes.
Yeah, everything just gets installed locally on your machine. You'll see it kind of spin up when you do it the first time. All right, yeah. So I'm going to show apps, but before that, real quick too, I have a quick just agent example that I thought I might as well show as well. And just want to also point out, let me zoom in actually real quick. Sorry, if this is more useful for people. If you're setting this up, and this works great on a Mac if you're running agents and you want to get like the durability piece and the visualization piece, which is really helpful for debugging and then also seeing how your agents ran over time. Just want to quickly note too, you can set up secrets in your local Devbox. So like you just say Flyte create secret, Anthropic key in this case, and then assign it to that project. So I have Flyte snacks there, like we were saying, that's kind of the default one. And then I'm putting it with the domain development. And then you run this, and then you'll just enter in your key, and then it'll be saved to your cluster. So as you run anything else in that cluster, you can just access this key, and you pass in the key as well in how you create the environments. And you'll show this a little bit already, but for basically any task that you want to show up in the UI and be run in the Flyte runtime, you define an environment, and then you could define multiple environments. So you might have one task with minimal compute, and you might have another task with way more compute, maybe a GPU if you're doing like a small language model for an agent or something like that in this case. And then you can also define the secret. So we define the Anthropic API key, and then we're going to read it into our Flyte environment as the same in this case, but you could have a different name here. And then in this case, I'm reading from a requirements.txt, and that's going to be the image. The Docker image gets built with that, and then it'll run in there. So if I'm going to run this pipeline real quick, that's a Flyte workflow. And this actually does a quick little agentic search and writes a report, and it uses Tavili. So I set the Anthropic key and a Tavili key, and then I'm just going to go and run the query saying, I put a spelling error in there, but let's see, it should work. The latest AI and biotech use cases. And then I'm going to give it some parameters here where it can search 3 topics at a time, and then it can do 3 searches within those topics and then iterate. So if the quality doesn't fit what it wants, then I'll opened in a different window. If the quality doesn't meet its standard, then it's going to kick off that search again. You can see in the side here that our agent's running, and then I click into each of these executions and see how they're doing. So these searches here are actually a trace, so they're running within that task, but we can still see the input and output from, in this case, it's a search result from Tavili, and then it gets returned and actually generates a mini report here with the things that it found from that one search. And you can see that it's doing 3 in that topic, and then it's going to combine all these. That's what it's doing now, is synthesizing them into one bigger report, and it's going to do a quality check on that. And then if it doesn't meet the standards, it's going to kick off the search jobs again, and then make another report once they're combined. So reports are a way you can also embed HTML markdown directly into your tasks here, which is really useful for a lot of different things. For agents, something like a report is really nice. For more traditional ML workflows, you can embed your training metrics. And then so every time you come back to your runs, you can always go and see like what was the input, what was the output of that whole run, and then have even reports logged there. So actually, if I go back to my UI, oops, maybe because I'm streaming at the same time with my internet, maybe. If I go back in, here's one that already ran. I can go look and see the final report here, and it gives it like a quality store. But this is just a quick example of showing like agents in the runtime too. And this works great on a Mac without a GPU. You can use this super easily. So then I'm going to show apps. I have a few different ones here. Well, first I'll go back in the UI. I can click into the app tab. You can see that I have several here. I have the Gemma 4, 26 billion, active 4 billion deployed here. So this is a deployed model that now gives me like a URL that I can pass into other apps or just query and then use it as a hosted model. And you can see it has replicas 1 of 1. So there's also scaling built into the apps, which I'll show in the code here in a second. But you can define scale down, like if it hasn't been pinged in 2 minutes or 15 minutes, whatever it is you set, then it'll automatically scale down. Actually, I found this is really cool for hosting models in my DGX Spark because I do multiple things all the time on there. So I can just serve this model up. And then if I haven't used it in a while, it'll auto scale down. And then next time I'm SSH into it and want to use the GPU for something else, I don't have to worry about like cleaning up that model being loaded into memory, which is pretty cool. And then I have a few other hosted apps here. Chat UI, which I'll open up. Let's see. Yeah. Okay, cool. It spun up very quickly. And we'll just say, hello. Let me zoom in. I don't know how this app's going to look zoomed in, but I wanted you to see it. So, hello, you're running on a DGX Spark in Flyte 2 Devbox. This is just going to the Gemma 4 model. So let's see what it says. You see it's doing some thinking here. I have the thinking enabled. Which, by the way, Gemma 4 loves to think. So sometimes you might want to throw in a thinking cap, which I actually have built in this Gradio app. If you do want to mess around with it, I can share the link here. But you can actually put a thinking cap in to be like, only think for 200 tokens or 1,000 tokens. Because I've had situations where, especially if you're using the 31B dense model, it really thinks. Like one time I had it stuck thinking for like, I swear it was like 30 minutes or something, and it wouldn't get to the output, which was kind of wild. So you can see it did a lot of thinking. It probably, doesn't know what Devbox is yet because we just launched it, so it wasn't in its training data. And then it's giving me a fun little thing though. It says it sounds like an incredibly powerful stack, which it's not wrong. And it probably is familiar with DGX Spark. I think it was trained on that. So if you are indeed running environment backed by DGX Spark, you got a massive GPU compute at your disposal. Yeah, so this is this is pretty fast token generation too. I know like some people will say the DGX Spark is a little slower than some other GPUs, but for hosting a model like this with the at least 4 billion active, and I've done it with the 31 dense, it's really, really fast. So you can see like, I don't have a problem with the token generation. Of course, now in a live demo, it's taking a second. Again, it might be because I'm streaming and SSH'd in. Yeah, so super fast token generation. And to deploy an app, so I have a couple other ones I'll show, like a really fun vision one. But to deploy an app, it's pretty similar. Like how we saw, this is how we create an environment for the Flyte tasks. You do very similar things with your chat environments. So you just say, you give it an image that you want to deploy it on. You define an app. So you pass in things like, again, what do you want it to run on? In this case, this is the Gradio app, and the model has a GPU defined here as well. But the same thing, you pass in different parameters. You could pass in requires auth, although I guess for your local host, this might work differently. But if you're hosting on a Union app, you can say like requires auth or not, and then you can pass it to someone who's not logged in and have a deployed app there. And then you can set scaling. So how much replicas do you want to spin up? In this case, I'm just running on one machine here with one GPU. And so like Niels was saying, maybe we can get a few more sparks and then mess around with auto scaling might be really cool. But in this case, I just have it to go up to 1 to 0, and it's going to scale down. I think this is like 30 minutes. If I haven't used the app or I haven't used the model, I'll automatically scale it down there. And you just define like an app or like Fast API or a Gradio app kind of as you would normally, and then it gets hosted in the app space. And then so here I'll show another really cool one. Caveat, because I'm doing this in stream, I'm going to open up my camera, and sometimes this goes weird. So let's see what happens. I think this is going to open up my my other camera, and so this might work better. Actually, let me try to set it to that. Okay, so allow. I'm going to hit record, which turns this on. I have a little thing here, so it's you can't see me the whole time. Let's see what happens. And hit start, and this should start pinging the model. Again, maybe it's because I'm streaming here. If this one doesn't work, I have another vision one. This is I wasn't sure if it's going to work well while streaming. Let me try one more time real quick. Maybe I'll select a different camera. Because yeah, for some reason it's not pulling in my frames here, which I think might be because I'm streaming at the same time. I have a recorded demo of this. Works great. It's worked great every time except for when I'm live streaming. So something's up with that. I could try that again a little bit later if we wanted to. But I'll bring in an image here. We have, actually, instead of describing it, we show you too. So this is running Gemma 4 for images, and you can do things like have it describe what's in the image, or in this case, I will have it annotate what a class in the image. I think the upload speed for the frames is just really low while I'm streaming right now, and that's probably what was happening on the other one as well. So I ask it to label people in the image, and then it does do some thinking behind the scenes. I didn't show the thinking tokens on this app here for the bounding boxes, so it's actually thinking behind the scenes here, and then it'll return, in this case, bounding boxes around the people here. So really cool ways to deploy different types of applications, and the models deployed in the Devbox too. So you get the auto scaling type of pieces, and they interact with each other really well. And then if you're doing something like training a model or fine tuning a model, and you want to bring that model over to an app hosted in here, it's incredibly easy. And they share the same environment in terms of like how to build Docker containers. So you get less of like the potential of environment skew happening too, which is nice. Oh, and I see someone had asked, I think Neil's already answered the question. Is each app hosted in its own container, or are all apps are all apps in the single Flyte dev container? And Neil said, each app is hosted in its own container. And so that goes back to the kind of building piece. When you're defining the apps too, you define the image just like you do with the tasks, and it's going to build this image when you run it. So there are a couple of different ways of deploying this. Is like you can run Flyte. If I run this right now, it's going to take a while for the model. But if you run Flyte serve, and then this is the Python file name, and then the app that we defined below, VLM app, this will then serve it up and build that image container and then serve it. You can also serve directly with the Python SDK too. So you can run things like Flyte serve, Flyte run, but you can also do all that in a Python SDK. So you can have it where you run like just a .py file, like Python run Python, whatever Python file name is, and then you can actually do like Flyte.serve or Flyte.run inside the Python SDK directly as well. Any other things you wanted to add?
Yeah, I think that's pretty much it. I think as you can see here, Flyte is no longer, if you're coming here from Flyte 1 or kind of aware of orchestrators from the previous generation, Flyte 2 is a kind of a very different beast. So as you saw here, it's more of like an AI development platform. There is orchestration here, of course, with tasks. We're orchestrating not only the data flow and what runs when and in what order. We're also hosting apps. we're also, so you can build things that interconnect apps and tasks, things like this. So it's a little bit broader, I think, in terms of what it can do now. Like it was impossible in Flyte 1 or in a traditional like static DAG orchestrator to build things that you're seeing on the screen right now. So yeah, it looks like the VLM is working now. Nice. Yeah, that's awesome.
Yeah, I think the issue is just I was SSHing in, and then sometimes if you're passing frames through SSH, that's like takes way too long. So actually, one fun thing is that if you're doing Gradio, if people know, Gradio has like a share type of thing, and it'll give you a public URL that you can then share out or use like somewhere else. And I have that enabled inside of the Flyte app. So this is running in the Flyte container. But then if I go and look, I actually get a public URL that I can access. And so that makes it easier if you're doing something like live streaming images specifically is the use case where I've just run into that issue. And then this one just keeps a little context. It queries a frame every 3 seconds, and then it keeps a context of what was happening for the last like 5 frames. So it actually can have like a narrative of how the scene changed over time. Like it'll know there's a person, and knows that person lifted up a cup, maybe took a drink from the cup, which is pretty cool.
Yeah, and so just to give everyone a sense of our next milestone, the Devbox actually is like the full production thing. So it is literally all the services you would host yourself on AWS or Azure or GCP or whatever cloud you want that's supported. Those are the three main ones. So yeah, again, Flyte is nothing but like a backend that makes sure it like can schedule jobs and schedule compute and build on top of Kubernetes. It's the UI. It's the Postgres to keep track of state, all the metadata, all the inputs, outputs, metadata, and a blob store. So that can be S3 or GCS or Azure Blob Store. So those are all services that are being stood up by the Devbox. The next milestone that we're shooting for in June is the full GA release for Flyte 2. So we're super excited about that. Really, the delta, just to be, to give everyone a sense of what's left to do, is literally all the Helm charts, all the kind of the Kubernetes related values files, YAML files, all the infrastructure kind of artifacts that you need to stand up the infrastructure on your cloud and make that really nice and easy to interact with. So that really is the delta between now and in June. So we're super excited to get that out as soon as possible. Yeah, I won't reveal too much, but we are thinking about how to make Flyte 2 more AI native. So look forward to skills related to not just authoring these tasks and apps, but like how do you even set up a Flyte cluster and maintain it? So we're in the world of agents and agent harnesses, and surely we can do something there to make it easier to get started with Flyte. So that's another thing. Yeah.
And Claude, if you like, sometimes some of the models will by default, if you don't give it context, like still spin up some Flyte v1 code. But if you give it just like one example or a few examples that exist like in the Flyte SDK or in the workshop repo or anywhere like that, if I give those examples to like Claude and I ask it to build a workflow with it, it does a really, really good job because it's pretty simple. The SDK is your defining the environment, kind of like we talked about, and then any task or like an async Python task, you're just wrapping with a decorator that basically tells it to run that as a task with that container in that environment. So pretty easy. And then the big difference, or one of the big differences from V1 and V2 is V1 had a workflow decorator that you would wrap all the tasks in that became like your your DAG that would get compiled for the workflow. In V2, you just have this task decorator, and the task decorators can run other tasks now. And it's pure Python. So if you were familiar with V1, there's a little bit more of a DSL. Now you just write pure Python, add these decorators in. You can do like loops and if statements, etc., in your workflow now. So it's dynamic, and then you get that tree that we kind of saw in the Flyte platform. Someone said they want to see the DGX Spark. Mine's in the other room, so I can't grab it. Niels might be grabbing. Oh, there it is.
Let me. Okay, I have my blur on, but yeah, here it is. Hopefully, don't unplug it. It's pretty. It's like this nice golden little box. I should probably secure it a little bit better. Just lying on top of my desk.
There are other versions that have the same chip in it with different, like, I'm pretty sure almost everything's exactly the same in it, but they have a different brand. Like, I forget if HP, there's a few of them that have basically are like another brand wrapper around the same thing. And sometimes I've seen them listed as slightly cheaper. I think they're usually normally all the same prices, but sometimes they might go on sale or something. You can save a few $100s if you keep an eye out for the other versions from the other companies, but it's the same Grace Blackwell chip and everything in there.
Yeah, there were a few quirks with getting Devbox to work on the DGX Spark. It just needed some new drivers, just because the architecture is a little different. So there's no like GPU memory; it's all unified memory. So there, just some insider debugging, just to let everyone know. Yeah, there were some quirks there that we needed to just make sure everything was up to date using the latest NVIDIA drivers and stuff.
And I run into that not even just on Devbox with anything I do on DGX Spark. If you are developing on it, it's awesome. And I've never had a thing where like I don't get it to work, but sometimes it'll be like, you just always have to make sure you're installing the right version of CUDA and stuff. And again, if you're using Claude or different AIs to do programming, they don't know about the version sometimes. And I've actually had them be like very persistent sometimes that like CUDA 13 doesn't exist. And I'll be like, no, it's out. Like, I'm using it right now. And it's like, they're like, no, it's not. And I have to like send it the PyTorch link to have it change its mind and stuff. It's kind of funny. So yeah, just when you're working on the most cutting edge stuff, some stuff's a little lagging behind. So but it's been an awesome development environment. And then with the Devbox on here, it's just such a good like AI development, like AI lab environment. Like, I'm just so excited to be using this all the time now. It's awesome.
Yeah, and I think because I think the industry sort of optimizes for models, even if they train foundation models that don't fit on this hardware, they will typically do like a distillation step or some type of compression to get the good models to sort of fit in like, it's 128 gigs of memory, which is a lot. You can fit pretty much all of the low double-digit foundation models, frontier models on it, and have enough memory to fit like the maximum context window. So it's pretty cool. And yeah, I think like just to tie this back to the Devbox, if you're to do any experimentation on the DGX Spark, you kind of have to, you have the file system, you have to roll your own like quirky way of like keeping track of models and files and data sets and all that stuff. But with the Devbox, it's all kind of abstracted away from you. Like, you can just train models, fine-tune models, host them, and like it all just works really nicely locally. So that's another thing I'm excited to kind of dig into. Is I think before both of these came out, I was it was just like constant FOMO. Like, models would come out and you won't really be able to use them. We would have to like host them on Union infrastructure, and I don't know. I feel like guilty spending money that way. But now it's
right. If you're doing like an auto research run, and you're running it for 12 plus hours or something like that, I'd be like, man, I'm hogging this T4 or bigger GPU from from the team and spending money. And then being able, like now with the Spark, is like you pay for electricity or whatever, right? But you're it's relatively low. So doing things like really long running auto research, which I did auto research with the Flyte 2, and that was really cool. And I'm excited to redo it again in the Devbox now with like the better UI and better experiment tracking will be really cool.
Yeah. Oh, one thing we will also work on is getting the TUI to work on a remote cluster. So if you're not familiar, I think Flyte Start TUI will start a TUI as long as you have like the right configuration set up. I don't know. Yeah.
I was going to make sure, did I install TUI in here? Because I can actually do the run that we did before. But I can say Flyte run. Oops. Have some lag. Again, while streaming and SSH. Local -- TUI. And then this will bring it up. So this isn't running. Oh, maybe I did install something wrong here.
Oh yeah,
I wasn't ready for the demo.
Yeah, you need an API key.
I need the API key. Yeah.
That's okay. So Flyte does ship with a TUI as well, and currently it only works with local persistence. So they're basically 3 modes. Maybe I can reshare my screen. It's in the docs. One sec. Okay. Oh yeah, how do I put my screen onto the... Oh, I think, you need it. Okay, cool. So this is the Union docs, which pretty much closely mirrors the Flyte one. So there are basically 3 run modes to run stuff, workloads on Flyte. There's local, so that's completely local. There's it's just running on your machine. No additional things needed. There's Devbox, which we showed off today, and there's remote of like a cluster that's being hosted on some cloud somewhere. So TUI currently only works with local mode. Maybe I can bring it up real quick here. Yeah. So this is a TUI for things that are persisted in a SQLite database somewhere. I forget where exactly it is in your file system, but so that sort of allows you to run stuff just completely locally. This actually will run on a Mac, right? So you can run like PyTorch with the MPS device on the TUI. But we realized it actually is super cool to be able to just access your Devbox or a remote cluster from your terminal. So you can do things just like you can look at a run, you can examine the run and the sub actions of a run. You can look at inputs and outputs and the task detail and things like this. So that's something we'll ship in the next month or so. Roughly around the Flyte 2 GA timeline. So you can just like connect to a Devbox or remote directly on your terminal. So, different strokes for different folks. Like if you like browser interactions and it's obviously prettier, then there's that. But some people don't like to leave their terminal. And so that's kind of the thing we're designing for many different preferences.
And you get already in the TUI too, a lot of the stuff that we had talked about with like you can save reports. They're just an HTML file though, but you can open them up. So you can still have a pretty report. It just doesn't get rendered as nicely in the UI because it's not direct rendering in the TUI, but you'll get a link to it and you can open it up. And then you get some of the durability pieces too of like retries are in there. So if you're calling an API with agents, for example, and the API fails, it'll automatically retry it a certain amount of time and you can overwrite that. You get caching as well, which is nice. So if you're running a workflow, you can cache specific tasks directly in the TUI. And then it's also, I found just the visualization of that tree is so nice for like specifically debugging agents. So if you're building agents that do a whole bunch of tool calling like at the same time, or spin up multiple sub agents. Once you're logging more than like 2 agents or something out in your terminal, it's really hard to keep track of what's happening. So having that directly in a tree, and then seeing like the green check mark when it's done, seeing that there'll be a little blue dot as it's running, or an X when it fails, just being able to see the status of everything in a tree is really, really nice for doing agent work. And then all you do there is just the UV or pip install Flyte, and you can set up one thing to have persistence, and then but you get that TUI just like out of the box for free. You don't have to have Docker set up either. So if you don't want to do things like running things in containers, that's not for you right now at that stage of whatever you're working in, then you could just use the TUI and get a lot of the niceties of Flyte.
Yeah. And this is like, again, maybe to surface a little bit of our thinking at Union, and as we continue building out and shepherding Flyte. Obviously, Flyte 2, we're going to have like efforts to get more contributors and more of a governance model in Flyte 2. But really, like the lesson we learned from Flyte 1, which was very much like geared as like a power tool for production grade ML orchestration. It's like it wasn't, you know, we inched closer and closer to like a good local experience, but there's a kind of like a gap between that. You can like run stuff locally, and then you can run stuff remotely. And it was sort of I would say less of a emphasis for us to like smooth out that on-ramp onto production. So with Flyte 2, we're really focusing and emphasizing sort of like, yeah, you can install Flyte SDK locally, you can get value out of it, just running stuff on your laptop. And as you can see here, the inputs and outputs, like the outputs are saved in these local temp file paths, right? So like you can go in and inspect them yourself. So this is basically the stand-in for the blob store. The SQLite file where all of this metadata is being stored is the stand-in for Postgres. And obviously the compute orchestration, there's like n of 1 node on your laptop, right? You may have like multiple cores and stuff, and so you can sort of scale that way. But then you have the on-ramp of the Devbox, which you can get a little bit more of that power, and then finally with the remote execution, which gives you the power of a cloud. And you know, we're going to eventually have a multi-cluster story in open source. The thing we are going to GA with in June will just be single cluster. But eventually you'll be able to like host a Flyte cluster on AWS or GCP or in different regions, depending on your organization's like security and data governance posture. So yeah, we're trying to do a lot here, but we're trying to make it like tractable so that any individual developer can get started with Flyte, and then as they grow, they will grow their Flyte usage with their story. So you may start just like playing around with some models locally, and then you may need a bigger machine. That's when you start doing stuff remotely.
Yeah, and if you already want it at scale today, too, you can go to Union.ai and check it out there. But
yeah, and everything in terms of the SDK, with one big exception, everything is portable, and the exception is reusable containers, which is a whole nother topic of discussion. But the entire like SDK API surface area, with that one exception, is like compatible across Flyte and Union. So we really wanted to make it portable. We didn't want to like lock anyone in. So that's the strongest Union pitch you'll hear today. Is like we're hoping that people write code in Flyte, and it becomes like a kind of simple standard way of scaling your AI workloads. And then, yeah, if you need more scale, if you need performance, if you need enterprise features, then Union is kind of the place. But the docs, as you can see here, you can get a sense of the different flavors of Union between Union and Flyte, and see where the differences are today.
Awesome. Any other? I know there's still some people here. Any questions from people watching the stream right now? I also shared a link in the chat. So if you have questions later or you think of them later, you should join our Slack channel at slack.flyte.org, and you can ask them there. So if you do think of them later, if you don't have any right now, join there. And me and Niels are both in there quite a bit, as well as over 5,000. I think we're going almost to 6,000 people now, I think, in that channel. So a lot of people to get help with on different projects, but a lot of Flyte and our other open source, like Niels is the creator of Pandera, if you happen to know that as well. And if you have any other questions on Union or Flyte or just ML stuff, we share a lot of stuff in the ML news channel. I think that's one of my favorite channels. You can check that out as well. And if there's no other questions, we'll probably wrap up the stream, but I just want to hang out a minute more to see if there's any that come in, because I know also there's a little bit of a lag of a streaming to you watching, potentially like 30 seconds or so. So just want to make sure we get your questions before we go work more on building cool stuff with Devbox. Or were there any features from what you saw today that you thought was pretty awesome? I think that's always kind of cool too. Like, did you like what you see? I mean, hopefully you did. I like it, but I'm very biased.
Sage, are you using Tailscale right now for?
Yeah, I was. That's a good question. So I was using just VS Code tunnels. So VS Code has a built-in thing for creating a tunnel that works pretty good, but I would get disconnected sometimes a little more than I wanted to. And like one day it was super slow. I think they had something on their end. And then when I was doing reports inside Devbox, you have to have another port exposed. And so you can do port forwarding in code tunnels, but for each port that you're forward, you have to open a URL and then click like allow. So for getting reports to render, I had to do that for all the ports. And it was like, oh, it's good. VS Code tunnels is really good for a lot of stuff, but it's a little annoying if you always consistently want to access like an app. So now I'm using Tailscale, and it's really nice because I can also just have like that IP address bookmarked, and with the Flyte localhost URL, and then now I can just click on that and then just access my Flyte from anywhere, even like without having to recreate my my login like I would have to on VS Code tunnels, because I would get disconnected. So Tailscale, I just actually have it up, and you have to SSH back into your VS Code tunnels, so like you'll get disconnected from that eventually, but you can always just have your Flyte app up, which is awesome. So I can kick off a run on the DJX Spark, be disconnected, and then access that. And I think I can even do that on my phone. I haven't done it yet, but sometimes I have like to look at runs on my phone in the past on Union. So I think I can do Tailscale on my phone, have the IP address URL saved, and then like access my Devbox Flyte runs and apps from there. So that's actually a cool thing, is like having an app and then being able to, again, access it from any computer that I have Tailscale on. Like that's what I was doing with the vision. That's what I ran into earlier. I think is if you're streaming images between something like that, it's usually not as good, especially if you're streaming at the same time, because I have done it before. But like I mentioned, if you're using something like radio, you can actually get a live URL and put it in the logs there. And someone asked, can they share the link again? They could not find it. Oh, I think I shared it and it only went over to YouTube. Let me share. Which link were you looking for? I'll share several. Let me open up the LinkedIn live stream. Make sure they get over there. That might have been for the Flyte Slack, maybe. I'm going to share that in there. And then I'll share a couple of the other links too. This was the Devbox announcement. And okay, just Union.ai. You can go to Union.ai and everything should be there for like if you want to book a demo or anything like that. There's like a big yellow buttons like chat with engineer. So you can book a demo with one of our engineers and then talk more about like your personal use case. But I put the Slack link in there too, and then the blog announcement if that's what you were looking for. Thank you for letting me know it didn't go over there.
I guess we do have, I guess, 6 minutes technically. One final point I want to make here about how we're thinking about Flyte 2 is that there's a lot of just like hand wringing and kind of categorization around what are agents and why do you need agents, and I think that's people are more and more convinced it's getting harder to ignore that they are useful, especially with coding, but with also a lot of other stuff. And we're also seeing moves in the market of a narrative shaping that orchestrators from the previous generation are like, oh, we've done this all before already. You're just rediscovering things. And these orchestrators are like pivoting. They're like creating brand new packages and products to support agentic stuff. Our thesis is that like Flyte, because it's named in such a way that it's agnostic to ML or data or AI, that's kind of nice. That agents are just going to be part of the stack. And so like ETL and data are still like a major workload. Like tons of people are still doing ETL. Maybe there's an agent in there doing some part of that work in that pipeline. Same goes with ML. Like people are still training classical machine learning models. Even the founder of like sklearn started a company, and they're, as far as I can tell, they're like doing good work, and they're trying to build sort of like products and services and stuff. So the previous layers of the AI ML data stack haven't gone away. And instead of building a brand new product, we're taking, there's a lot of overlap in architecture between Flyte 1 and 2. We built a bunch of brand new stuff, as you can see. But our thesis is that agents are just going to be part of the software stack. And, for the foreseeable future, like humans will still be reviewing a lot of code, maybe writing less of it. They'll be architecting stuff. So you'll be writing higher level specs and architecture. Also partially vibe written, but that's our vision of the future, is that agents will just be part of the software stack, and Flyte 2 makes it such that you can write Python code, agents. We haven't even shown you sandboxes yet, and our kind of code mode agents that are built into Flyte 2. But we're taking our time picking and choosing what is going to be useful in this kind of agent native orchestration, of orchestrating not just agents, but like everything that has come before it, since that still produces a lot of value for many organizations.
You mean traditional ML is still a thing? It's not just large language models?
XGBoost is still a thing. Random forests still work.
Sometimes I find it like, because I'll get absorbed in like the LM stuff for a while, and then I go work on traditional AI project. I'm like, oh yeah, this is so awesome. And like I'm doing a talk in 2 weeks on like object detection, like efficient object detection models that you put on edge devices. Like there's so much of the industry that doesn't just use VLMs and giant LMs for everything, right? Like if you're doing healthcare things, those can be useful tools, but like if you're doing radiology detection and stuff like that, I think a lot of it's still on the traditional AI side. Maybe now you have assistance with other bigger models too, but like training an object detection model is still such a high ROI for a lot of companies, and you're not using a VLM, and it's a lot more expensive to run a VLM. Like you have to have a DGX Spark or something like that, versus like you can run literally really good object detection models on like a Raspberry Pi if you're putting them in the field and stuff. So yeah, I don't think traditional AI stuff's going away anytime soon either.
Yep. I mean, a lot of the agentic applications that we're actually testing internally, we're doing a lot of like customer support and like the stuff that most other people are doing. We're also doing kind of like machine learning agents. So agents that write machine learning pipelines or data ETL pipelines. And a lot of our customers are also like starting to infuse some of their older, more established applications with some agentic sauce, So I think that's where the industry is moving, and Flyte 2 is gonna, it's gonna be really easy for people to kind of migrate the newer patterns, and then add some of that agent sauce in there for parts that were like where you need some non-determinism, you need some flexibility in the way you might pull JSON out of unstructured text, things like this.
Yeah, Flyte 1 was very widely used, so people are migrating over to Flyte 2, and I think I've heard nothing but good things. Like, people love it when they come over to V2. All right, so we're at the hour. I think we got to end the stream now. We had some other questions come in that we already answered, but thank you, Niels, and everyone came in, talking to the chat. Join the Slack if you haven't already. Asked questions there, and hopefully we'll see you at the next office hours and at our whole bunch of other events that we're doing. So like next week, I'm doing a workshop on building agents with similar to like what you saw here. We'll be using V2 with Union, I think. That's how I'm playing it right now. I was thinking about switching to Devbox, but I think we'll still use V2 Union so you can have a cluster and run everything yourself. So if you want to join that, check out again the Flyte site or the Slack or Union. You'll see it posted there. So thank you, everyone.
Thanks all. Bye.